Now that we know where the digital certificates are coming from and who we get them from and the information we send to the CA, all of that, let's talk about a digital signature because this is a separate deal from digital certificates. So you want to watch that on the exam. In this situation, Bob's going to send some data over to Dan, and Dan needs to make sure that that's really Bob sending it. That's why we're really doing all of this. Because even though we've got these certificate authorities and there's a little bit of trust going on, we're still going to do some authentication here. And that's going to come in with the digital signatures. Bob is going to do a couple of things to begin with. First off, he's going to run a hash algorithm against the data itself, resulting in a message digest. And that little term should sound familiar to you. And that is our hash. But we're not done yet. What we're going to do then, or what Bob's going to do, is take that hash result and encrypt it with his private key. Now note that it's not the original data that's being encrypted here. It is the result of the hash algorithm. It is the hash result itself. So now we've got Bob's data being sent over to Dan with an encrypted hash. That encrypted hash is attached to the packet, and that is actually the digital signature itself. So Dan gets that, and now Dan's got to do three things. First off, Dan's going to decrypt the hash with Bob's public key. Note that the private key is not being passed over here. He's going to decrypt the hash with Bob's public key. Now that he's got the decrypted result, Dan will then run that same hash against the data that Bob ran. And if it really came from Bob and nothing happened to it during transmission, what should be the result? That should be the exact same thing. If that hash result that Dan gets matches the decrypted hash result, the signature is authenticated. Now, if the results don't match, it doesn't necessarily mean that something evil has happened. It could be innocent, but it could be someone pretending to be Bob. And notice that's number one on the list here. Another reason that the hash results would not match is that the message was changed or corrupted since Bob signed it. You know, that's certainly a possibility. The third one here I've seen in some documentation over the years. It's left out of others, but a general error happened during the transmission itself. I know that sounds like a CYA there. Maybe it is. But most likely, if that hash does not match, either there was actually some corruption to the data, to the signature, or it could be someone pretending to be Bob. Now note that our friend, the certificate authority, is just sitting over there by itself. It's not involved in this particular part of the transaction. Dan's going to do all the work here. He's going to decrypt that hash with a public key, run the same hash. That hash result matches, etc. It's authenticated. If it doesn't match, then it's not authenticated because it could be someone else. But again, notice that the CA is all by itself in this particular transaction. A lot of important things going on here as far as signatures, what keys are where, and what keys get used where. So let me just point out one more time that that hash is encrypted originally with Bob's private key, and it's going to be decrypted by Dan with Bob's public key, because again, everyone has access to the public key, but hardly anyone has access to the private key. I'm actually going to stop this particular tape right here, because in the next recording, we're going to take a little bit of a look at the certificate authority. We're going to go over some of those fundamentals again very quickly at the beginning, and also we're going to take a look at a root certificate and where you can find them in at least one popular browser. You might think it's an unpopular browser, but we got to live with it, so you probably already know which one I'm talking about. And I'll see you on the next vid.